All right, so I thought I'd work an example of how to solve the empirical formula for you. And this one is, the problem given is 26.56% potassium, 35.41% chromium, and 38.03% oxygen. And so I'm asking you to find the empirical formula. Remember, I've said we're going to solve all parts. Sorry, this is off the screen. I'll slide it over. Solve all the parts. For moles. We're going to then divide by the smallest number of moles, and then you need to find the ratio in a whole number. Okay, so that's basically the process. Alright, so at the same time, we're going to solve these all at the same time. So 26.56, we're going to go ahead and make them into grams, assuming that we have a 100% sample. And I'm going to set up my work. So 35.41 grams of CR, 38.03 grams O, and I have all of them started. Alright, if you look on the periodic table, you can see that potassium is roughly 39 grams per 1 mole. Chromium is 52 grams per 1 mole, and oxygen is 16 grams per 1 mole. So you are going to divide these, and remember I have mentioned that you should carry 3 or 4 decimals. If you round too early, you run the risk of not having the right ratio. So don't round at this step. Keep several decimals. 3 is what I'm giving you here. Feel free to carry a little bit more if you wish. It might be overkill if you do too many more than 3 or 4 though. And the answer for this one is 2.377 moles of O2 oxygen. Alright, so now we have the mole numbers and we're going to compare them. We're trying to find the ratio. So how many K, how many CR, how many O? We are going to divide by the smallest, which happens to be the same for 2 of them. So we can see that it's 1, 1, and if you take the 2.377 divided by 0.681, you get 3.49. Now the point of doing this is to find a whole number ratio. We're trying to figure out how many K, how many CR, and how many O in our formula. So we're looking for these numbers that go here. We have 1, 1, and 3.5. And 1, 1, and 3.5 would not be a very effective empirical formula, the most reduced, because we need whole numbers. So in order to get 1, 1, and 3.5 as whole numbers, we're going to need to figure out a multiple that is still, the most reduced. So we could multiply these by 10 and get 10, 10, and 35, but that could be reduced down. So what you want to do is you're going to consider, what can we multiply these by? Usually you should start with times 2. And if we multiply these by times 2, and this is our new factor, we're going to have 2, 2, and 7. And 2, 2, and 7 cannot be reduced down any further, so it is our empirical formula, and it is the correct answer. If you're doing these and you get 3.3, you could multiply by 3 to get whole numbers. You do need to end up getting whole numbers for all the values of the substance in the formula, and it should still be the most reduced because it is an empirical formula.